So, welcome again, Happy New Year. We are starting strong into this new year by a very interesting webinar today from our Dynamic Mobility Nudge project with the title Using Data to Support Sustainable Mobility Behavior. And we have two great speakers today. I'm very excited for this. We have Dr. Martin Leudl from the University of Salzburg, and we have Sebastian Gatscher from Traficon. And yes, can we see the next slide so I can talk about the content? Thank you. So we are now in the welcome phase, and that's done by me. My name is Claudia Luger-Batzinger. I'm the senior researcher for this project at Salzburg Research, and I'm also the project coordinator of the Dynamic Mobility Nudge project. And it is my pleasure to be your moderator today for this webinar, to welcome you here and also to give you a short introduction to the project a little later. And then I will give over to my colleague, Martin Leudl. He works at the University of Salzburg as the head of the Mobility Lab. And he will tell us more about the use of digital data for promoting sustainable mobility. And afterwards, we have our second speaker for today, Sebastian Gatscher, who works at project engineering and research at Traficon. And he will tell us about the modular architecture of IT infrastructure. And afterwards, we will have time for question and answers. And if you have questions during the talk, please just put them in the chat, then we can go back to it later on, but we will answer your questions in the end then. And yes, without further ado, I think we can talk a little bit about the context of this project. And if you click the first slide, please, Martin, thank you. So within the Dynamic Mobility Nudge project, we are very much concerned with this scenario. So this is a challenge that many cities face, where people are relying very heavily on individual car use. And not only cities, but also we as researchers, we are asking ourselves the question, how can we go from this scenario to something that looks a little bit more like this? So where people are relying on more sustainable forms of mobility, such as walking, bicycling, public transport. And this is not only a question of a reduction of greenhouse gas emissions, this is also really a question of quality of life within cities. Because less car use means more room and space for people. It also means better air quality, less noise, and so on. And within our project, Dynamic Mobility Nudge, we want to help one step along the way from the left to the right scenario. And within the project, we are bringing together disciplines that are not always necessarily working with each other. So we have geography, geoinformatics, software development, and information technology, and they meet psychology, behavioral insights, and innovation. And we hope to go a little bit from the left to the right scenario. And specifically, the idea of the DyMoN project is on the next slide. Thank you. So if you want to have more sustainable mobility within your area, within your city, you basically have two different options of interventions. You can use soft or hard interventions. So hard interventions or hard measures mean things like laws, regulation, bans, also infrastructure. And they are not always possible. They are not always effective in themselves. And sometimes they can be very costly, especially when you think about infrastructure. So what is needed in support of these hard interventions are soft interventions. And these target really more the psychological side of sustainable mobility, like motivation, social norms, and so on. So we also need people to want to go from the left to the right scenario. So within our European research project, DyMoN, we want to offer digital data-based behavioral interventions, so-called nudges, to foster sustainable mobility. And for this, we are bringing together in this very interdisciplinary approach, as I said, different disciplines, psychology, geoinformatics, software development, and many others, to really provide digital data-based soft interventions to help with motivating people for sustainable mobility. And we have this webinar series. This is now the third part of this series, where we talk about results, insights, highlights, and also challenges that we faced in the project over the last 3 years. So the first two webinars are available for you online. You can watch the recordings there. The first webinar was about an introduction to sustainable mobility from a geographer's and a psychologist's perspective. The second webinar was about digitally enabled behavior change for sustainable mobility, so more the psychological side. And today I am very interested and very excited to see what our colleagues have to say about the more data-driven, technological and IT side of the project. And with that, I want to give over to my colleague, Dr. Martin Leudl from the University of Salzburg.
Thank you, Claudia, for this kind introduction. Welcome, everyone. As Claudia said, my name is Martin Leudl. I'm working at the University of Salzburg, and my background is in geography and geoinformatics, working at the intersection of mobility research and GIS. My plan for today is to give a short intro to what digital data are and what we can do with them in promoting sustainable mobility. And I want to say right away that we do not, or we cannot expect anything from data as such. But data can be used in tools, which in turn are an additional opportunity next to the provision of adequate physical infrastructure to promote sustainable mobility. Just to get this right from the very beginning. Let me use a couple of minutes on what I mean when we talk about digital data or data-driven interventions. Data and information, and I will come back to the difference between data and information in a couple of minutes. Data and information are abstract concepts of reality, comparable to our language. So we are used to name, or first identify and then name entities in our world around us. I will leave any aspects of data models, data structure and stuff like this aside for today. They are very much depending on the implementation. On the left side of the slide, you see a snapshot of a real-world situation as we know it from our daily traveling. And if you look at this picture, you can easily identify different entities, different objects there. So, for instance, you see the footpath and you see a cycleway. You see some natural objects like trees or rivers and built environment like houses or other buildings. You see those who use this road space. You see cyclists in this picture. They are moving on the cycleway. You see traffic signs, which are a physical representation of legal rules. They organize and regulate the road space in this case. You can see that the sky is blue. You even see a little bit of the sun, so you can see that it is bright weather, so good weather conditions for cycling. If you take a closer look to this picture, you might see some road dirt or even leaves of grass. Now you can form categories, and with this you do the task of abstraction. And depending on your purpose, depending on the scale and depending on the resolution, you might identify different entities, different objects. And obviously, the road dirt or the leaf of grass are not on the same level of abstraction like the cycleway or the river. So we have different levels of abstractions. And if we're talking about data, we need to be aware of these different levels of abstractions. We will come back to this in a second. What we already recognized is that all of these real-world features have a geographic reference. They can be located on the Earth surface. Thus, we speak of spatial data. The power of geographic information systems, which are abbreviated with GIS, is that a GIS can bring together various layers of data and information from very different domains. And you use the geographic space, the reference to the Earth surface, as a common reference or common denominator, where you can bring together these various layers. And then you can relate these layers. You can investigate these relations. All of you know such applications. For instance, if you use your smartphone to find the next bus, your location is used and is related to the locations of all bus stops. And then the next bus stop is selected, and you can check the timetables or the live data of departures of the buses there. So two completely different objects, you and a bus stop, are related based on a common geographic reference. This is what a GIS basically does, or how we use it. And the application, like finding the next bus stop and checking the schedule, is not so much interested into the data that is behind, but the information, right? So we are not interested in data, but in information that can be extracted from data. I already announced that I will go into this a little bit deeper by explaining the difference between data and information. So here you see a table, which is not meant to be studied for now, but the table only consists of some text snippets and some numbers. You cannot make really sense out of this. This is pure data. You need a context, in this case it's the column heading, to make sense of the data. And this making sense of is what we call information. So now we can extract information out of this. In this case, it is a snapshot of a crash database. So you learn about what type of crashes, who was involved, who was liable, etc., etc. But it is only the context that makes sense out of the data. And then we are talking about information. And now if you add an additional data layer that is the geographic location of each of these crashes, you can map this information. And now you're talking about spatial information. And you can pose now all sorts of questions like, where do most crashes happen? And everyone who looks at a map, like you can see it on the screen now, immediately sees patterns, spatial patterns that are popping up. And this is how we kind of relate very different information that has several data sources in the back and now can investigate them. In our context of sustainable mobility, we distinguish between certain types of data. It would take another couple of hours now to talk about how to represent the built environment and its organization. I will leave it for now to just say that for most mobility-related applications, it is sufficient to represent the road space as a mathematical graph or as lines, right? Every road segment is represented as a line. If the lines are connected, we have a topological correct graph. And then we can assign all sorts of additional attributes and information to this line, where we can store information on the road design, on the lane width, on the number of lanes, on the question whether there is a sidewalk or a cycleway, etc., etc. This is how we represent the built environment and its organization. And when I'm talking about organization, I mean things like access rules or speed limits, etc. Then we have the natural environment, which is also more or less static, like the land use. In my first slide, I showed you a river or buildings and stuff like this. And this can be represented by aerial data. And with this, we bring in all types of data that is representing the natural environment. And then we have some dynamic variables that are relevant for our topic, like the weather or the level of pollution or the velocity of the traffic or the occupancy rate of public transport and stuff like this. These are all data that is updated way more frequently than the natural and the built environment, which remains more or less stable. And our goal in this project was to bring all these different types of data together and make sense out of it and use this data for nudging purposes, as Claudia explained. I will come back to this. Before I try to reconcile these two concepts of nudging and data, let me go back to our understanding of sustainable mobility. I reiterate the definition now. I already presented it in the first webinar, and you're very much invited to go back to the webinar first if you weren't with us back then. So we understand sustainable mobility as the provision of infrastructure, services, technologies, and information to enable access to goods and services and participation in activities in a manner that, like all other forms of sustainability, allows for the continuation of such access and participation across future generations. So it is about now. So what can we deliver, provide now? And how can we do it in a way that we can also enable access for future generations? And most of you might be familiar with the 3 pillars of sustainability. And obviously, it is about balancing out these different interests. But as I've said, I won't go into further details for now because we talked about it in the first webinar. Our dear colleague Stefan Gößling nicely summarized 3 pillars of that are necessary for a comprehensive promotion of sustainable mobility. The first 2 pillars, the viable alternative transport offers and the investment in infrastructure, very much refer to the built environment and the services that are provided there. So it is about connecting places, it is about connecting different modes, and it is to provide an appropriate level of, for instance, public transport services. The second one is the investment in infrastructure. Obviously, you need safe cycleways, for instance, to promote cycling, and the same holds true for sidewalks and pedestrians, obviously. Today, we are more interested in the third pillar that he called communication strategies, and we want to focus on this for today. And it is about targeted, effective communication with the ultimate goal to shift our mobility towards sustainable mobility. In the DyMoN project, we investigated how digital nudges can be employed for this purpose. And we have 2 sides here. One is the societal goal of a reduction of greenhouse gas emissions, and in turn, the promotion of sustainable mobility. So this refers to the societal aspect, the collective behavior. But this collective behavior is nothing else than the sum of individual mobility behavior, which is largely habitual. Nudging now addresses the choice architecture of individuals. And this is well known from, for instance, grocery stores, where the products are not presented randomly, but in a way that they kind of steer you towards those products that are particularly featured, or that the shop owner wants to present to you most prominently in order to sell more of them. So we know this from this context, and we take the idea and bring it to the mobility sector. So the question is how to design the choice architecture in a way that people are steered towards sustainable mobility. For these nudges, we use different strategies. And again, I don't want to go into details here because Claudia and David did a great job in webinar 2 to give more details on this. So I want to invite you again to watch the webinar 2 or consult our DyMoN handbook where you find all details. The point now is that these strategies are rather well established in, for instance, health and sports exercises, but less in the mobility domain. We wanted to go a significant step further in this DyMoN project by considering the individual situation instead of just promoting something or providing incentives or providing information or prompt to action on a global level. So we wanted to consider the specific situation of users and then modify the choice architecture in a way that users are encouraged to use or choose sustainable mobility options. How this works, I will demonstrate in a few minutes. The choice architecture in our case, the context, so to say, is the environment. In this study from the Netherlands, the decisive factors for how we choose our modes are summarized. And in our case, for today, where we're talking about digital data for promoting sustainable mobility, we're talking primarily about external factors, not so much about the values and habits of the individuals, which need to be addressed in good nudging strategies as well, of course, but we are talking about things like the season or the weather and the built environment. How big the effect of the environment is can be learned from a remarkable study from James Sallis and colleagues, which was published in The Lancet. And they found out that the design of the environment, in this case, it was quantified or assessed in terms of walkability, how friendly an environment is for pedestrians. And they found out that the difference between the least walkable and the best walkable city that they compared is 20 minutes per week more physical activity, only because of the design of the environment. They controlled for all sorts of co-variables and really found out that the environment accounts for a remarkable amount of what brings you to move actively. Our task now is to link all the factors that are relevant for mobility decisions with the digital representation of the environment. And this is where our very brief introduction into the theory of data comes in again, right? So we need a digital representation of the environment in order to link this with the interventions that we are providing. Schwelkut does from the human-computer interaction research provides a handy conceptual approach which we took and translated to our case. So we use the data, we extract the information that we need, we identify situations that are relevant for mobility decisions, and then trigger the nudges at specific points of time and specific to the location of the user. So in other words, we use the timestamp and the location of individual users as a key for delivering appropriate nudges. And this is how it looks like on a conceptual level. So you see on the very left, the nudging repository. This is a collection of all kinds of nudges. And you see the individual user represented as a user of one of the clients on the right side. And I will now briefly go through these different components. Starting with the nudges, it is important to distinguish between two types of nudges. Each nudge has some sort of situational link, either directly, which is on the left side, or as a condition. As mentioned earlier, situation information can be semantically packaged in a nudge. In this case, you read most roads are congested and weather will be dry the entire day. Why not take the bike to work? This is like one of the nudges. You have two situational pieces of information there. First of all, most roads are congested. In order to find this out, you need some data on the velocity of the traffic in the roads there. And this can be measured by any sorts of traffic sensors. And the weather will be dry, so you need some weather data. In this case, it is a forecast, so you need the appropriate models, like you know it from your weather apps on your smartphone. In this case, the semantic information on a situation is directly included in a nudge. In contrast to this nudge, why not take the bike today, does not refer to any situational condition, but it comes along with the condition that this nudge is only used if the location of the user at this point of time is at home. So he or she has the opportunity to choose the bike or not. And the bikeability around the current location is high, meaning it is easy to take the bike. And so you can now check how is the road design around this location and how suitable or safe is it for cycling. What we do here now, and I think it's not that hard to understand what's going on, is conceptually and technically not that easy. We need to formalize the relation between a situation and the data, and we call this an ontology. If we're talking about temperature, we need to define what do we mean by temperature. When we say walkable, what do we mean by walkability? So we really need to define this on a very detailed level and in a very formalized way in order to use it. And then we combine these ontologies with rule sets that orchestrate the management of the delivery of the nudges. So you can think of it as a layered architecture, and starting at the top, you see the nudging repository. These are all nudges that are available. And you have some sort of information on the user's mode preference and his or her current location and the time. And then you consider the situational factors as I explained it before. And if you're thinking about these layers as filters, you get a list of nudges that are relevant, and from which then you can randomly select one and deliver it to the end user. The opportunities for such an approach have become increasingly better over the past couple of years, and this is because we moved from data scarcity to a data deluge. And we are now invited to use this data. And just to give you an idea of what we are talking about, so the forecast is that we will produce as a global society 264 zettabytes data per year in 2027. And just to give you an idea, 1 gigabyte is 9 bytes. 1 zettabyte is 10 by 21 bytes. So this is an incredible amount of data. In our particular context, we are interested in data that is generated in a, for instance, urban context, like smart cities, where a lot of data emerge from all these digital services and infrastructure that is out there. However, to make use of this huge amount of data, we recommend a planned approach instead of a what I called pragmatic or opportunistic use of data. So it is very important to define the purpose of your application right in the beginning. And based on this, you need to define the scope. So the content of the data, the content of the information in the end you are interested, the temporal scope, the spatial scope. So are you interested in a global application or only for one city? This makes a huge difference, obviously. And then if you know what you want, you need to translate this information demand into a data demand and a data assessment. So you start with a verbal description of the information. You define the extent and resolution. You are clear about the project aim, and then you can translate this information into a formalized data set description and a data assessment. And we recommend assessing the data that is available before you start acquiring the data. It's only the last step in this workflow where you really acquire the data, and it makes sense to invest quite some time into getting clear of what you actually want to do or need to do with the data. In our specific case, we did a proof of concept field test, and we tapped very different data sources, of which the majority was available as open data. And if anyone from public administration is in the audience, please, please, please promote open data in your organization. This helps a lot, not only for research, but way beyond. In practice, we access the data using standardized interfaces like APIs, and then processed the data and stored the data and managed the data in a way that we could work with it. We built our infrastructure on a server. We had a database there. In this case, we worked with a centralized data storage. However, the concept that we developed in DyMoN is also able to work with a decentralized data organization. In this database, we stored a table with all the nudges, that is the nudging repository. We stored all the data sets, which were automatically updated in the case of dynamic data. And we had the ontologies and the rule sets on our premises. It might be easier to get a visual idea of what we did. So we could demonstrate with the graphical user interface the technical feasibility of this architecture with live data, with real data. So just to give you an impression what this is, so we have for instance, the work location, we have the current location of a user and the home location. And based on this location information, we can select appropriate nudges that are relevant for this particular situation where the user currently is in terms of, for instance, the weather, but also in terms of public transport service quality, about the walkability and bikeability. And then one nudge is randomly selected from a set of potentially suitable nudges. How this looks like, you can see in detail on the next 3 slides, and I will briefly walk you through them. So what you see here are 2 scenarios. We have a cyclist, someone whose preferred mode is the bicycle. And in scenario 1, you see how the geographic coordinate of the current location is prompted to the server. We then receive the information on the weather. We receive information on the bikeability at this particular location, and then select a nudge that fits to this situation. In this case, tomorrow is a great day for taking the bike. Prepare for your trip to be on time and don't forget anything, because everything is like ideal. It is bikeable. The weather is going to be nice. On the other hand, there is the same scenario, but now the weather is going to be not that nice. We expect rain. In this case, the nudge is a different one. In this case, with your rain jacket, you can cycle to work tomorrow despite the rain. You can do it. So this is a motivational nudge that takes into account that it's going to rain tomorrow. And all this is done automatically. Now we have the same thing with pedestrians. So again, if your preferred mode is to walk, we check based on the location and the timestamp on the weather conditions, on the walkability, and then trigger the appropriate nudge. We can also do this for public transport users. It looks the same. So again, we take time and location to get all the necessary information about the particular situation, and then the appropriate, so to say, user-tailored nudge is triggered. So far for today, I want to wrap up with 4 learnings and then hand over to Sebastian. First of all, what we learned is that, as I've said, the amount of data that is out there is incredible. So data availability is not that much the issue. It is more about data accessibility. And again, if you have data, make them accessible. However, if they are accessible, it's not the same like that they are suitable for your specific purpose. So it really makes sense to assess the data before you start acquiring and working with it. In general, for applications like ours, it is not necessary to generate your own additional data. You can use data that is usually out there. Second learning is that it requires quite a lot of expertise in all this data handling and data modeling stuff, but this is not enough. You need to link it to domain knowledge, in our case, even cross-domain knowledge. So it was quite a tough road to get to the point where psychologists were able to talk with those who were responsible for the data infrastructure, and to bring them on the same playing field, so to say. But it was a challenge that we accepted and where we succeeded. We were able to automate the entire workflow, which is really nice because the architecture that we developed in DyMoN is more or less ready for operational purposes. Of course, we would need to scale it up to an operational level, but it works. We could prove the technical feasibility. And a benefit of the architecture that we designed is that it is ultimately adaptable. And this brings me to Sebastian, who will elaborate on the architecture now. So I will stop my presentation and hand over to Sebastian.
Yes. Thank you very much. So hello everyone, and welcome to my webinar on modular architecture of IT infrastructure. My name is Sebastian Gatscha, and I've been working for Trafficon for about 7 years now, mainly as a front-end developer and data analyst. So I'm certainly not the biggest expert in IT infrastructure, but I'm excited to share how we structured this project and more broadly how we handle bigger projects at Trafficon. I will start with a simple introduction to the technical basics and tools that we use, and then we look at the architecture and the infrastructure of the DyMoN project in general, before going into more details of the project, the back end and the front end. So what exactly is IT infrastructure? We can picture it as the backbone that supports and connects all digital activities within an organization. So you would start with the basics, the computers from the employees, but then you also have all the servers, the networks, databases, or different kinds of data storage systems and file storage systems. Then you would add all the programming languages and frameworks and a lot of other handy tools that make a programmer's life easier. Why do we use modular architecture? Well, software used to be this monolithic architecture. And I remember when I started to develop web applications or algorithms, I would put everything in one big file, and that could easily end up with many thousand lines of code. Back then, I was only happy when the code was running and didn't throw any errors. But that the whole thing would now be called spaghetti code, since it all looks tangled up and very confusing. So the new architecture is this microservice architecture. You can see here it's all split up. So it's a method to break up this problem into smaller and more manageable parts. And the goal is to have independent and interchangeable elements that can be developed, deployed, and maintained separately. And you can think of it as this Lego block structure. Each block represents a module. And at the foundation, you would have an operating system. Then come all the low-level programs that make basic computer functions happen. And as you move up the pyramid, you get higher-level programming languages, not necessarily because they are fancier, but they're more human-readable, and which makes them easier to learn, read, and write. So in the end, it's about breaking a big problem into smaller, more manageable parts, like building with Lego. So one tool that we use extensively is called Docker. It is an open source software that helps to create, launch, and manage applications in containers. And you can see here the logo of Docker is a whale carrying many shipping containers on its back. And so you can imagine this container as a bundle that packages up all the important stuff, like an operating system, all the code you need, services, databases, libraries, and so on, and makes sure that the application works the same way, whether on a computer, in the cloud, or anywhere else. And to explain those Docker terms, I will use a kitchen analogy to make it more clear. So Docker itself is like the kitchen where you prepare your favorite dishes. The Docker file would act as the recipe. So it's a set of instructions that tells the kitchen how to prepare a specific dish. That's a text file that you have to write yourself. Once you have your recipe, you can create a Docker image. So this is like a pre-prepared dish that is ready for cooking. But before you cook it, you put it in the fridge, the Docker registry, and then you can access that dish from anywhere you want, anywhere in the world. Docker container then is the dish that you're actually cooking. So you take it out of the fridge, put it in the oven, start the cooking process. So Docker container is a live running instance of your Docker image. And Docker compose is like you want to cook multiple dishes at once. So you have, imagine you have like a chef's assistant who helps you with the cooking process for multiple Docker files or recipes. And the other tool that we use is GitLab. It's a version control platform, very similar to GitHub, and it helps teams work together on software development. It includes tools for managing code, tracking issues, and automating tasks like testing and deploying. And since it's a version control system, it helps to keep track of changes in the code. It's almost like a time machine that allows developers to see what the code looked like at different points in the past. And it also helps to find out who to blame when an error is found. Then we have GitLab CI and CD, which means continuous integration, continuous deployment. Those are features within GitLab that automate the testing and deployment of code changes. And here's a little breakdown of how it works. So let's say you made changes to the code down here and you want to publish them. So you press a button, publish button, which is here referred to as a commit. As soon as GitLab receives that commit, it will start this CI pipeline. And in that pipeline, several individual jobs are listed, like building the software or building or downloading Docker images or pushing it to a Docker registry, testing the code and deploying it to a specific server. Those jobs are carried out by so-called runners. They are like agents on a virtual machine that execute your jobs. And both the front end and the back end use those technologies to test and deploy their code. Here you can see a visual representation of the DyMoN IT architecture. So on the right-hand side, you can see the data sources, mainly the data hub. But we also integrated data from the sensor API, which gave us information on noise and temperature in the study area. The DyMoN API is, as you can see here in the middle gray box, is responsible for the communication between all the systems. So the data sources and the end users. In our case, it was the dashboard and the Pandocs app. The API itself is a service-based orchestration of different Docker modules and that are all written in Python. And they communicate in an event-driven architectural style, which is a method of communication where systems respond to events rather than continuously checking for updates. So what does the backend or the DyMoN API actually do? There are two main workflows that can be distinguished: the nudging in the Citizens app and data visualization in the dashboard. The first workflow nudging starts in the DyMoN API with the nudge scheduler, and it requests user information from the Citizens app. It receives that data, and with that information, it creates nudge requests per user, sends those to the data hub. The data hub calculates those nudges, sends them back to the API. The API again forwards it to the Citizens app, and it can be then published to the users as a notification. The second workflow starts in the dashboard, which is very data hungry. So it makes a request to the DyMoN API. The DyMoN API forwards this to the data hub. They calculate data and spatial layers, sends them back. DyMoN API again forwards it to the dashboard where the data can be finally visualized. I'm very quickly going to show you the Citizens app, which was this app called Pandocs in our case. So as you can see, it's a healthy lifestyle and fitness app with workouts, step counter, healthy recipes, etc. And here on the right, you can see a Pandocs notification with a situational aware nudge. So let's jump to the front end on the dashboard creation. So it all started out with the brainstorming phase, where we crafted the first vision for the dashboard. Up here on the top right, you can see this was the result of the brainstorming phase. It's a little mock-up with some description text. And then we went on to the design phase. So we created multiple mock-ups, presented them in a workshop to several smart city managers, and together picked the best one. And then this was the final illustration that I received to create the dashboard. So we didn't actually go up in complexity here. The dashboard was implemented using the React framework, which is a JavaScript library developed by Facebook to simplify the process of building user interfaces for web applications. And its main features include the ability to create modular and reusable components. So React itself strongly emphasizes this concept of modularity. And since for me, it was my first web application in React, I used quite a bit of ChatGPT to help me along the way and teach me. And also, since the API was written or followed a certain specification, which works very well with React, I could simply very easily integrate or import the API, which would automatically create a lot of template code, or I would even say automatically sometimes. So here you can see a screenshot of the final dashboard, but I'm just going to quickly show you the real dashboard, as I think it's more fun to explore. So on the right side, you have this map with many different layers, background layers. I will pick the light one. And here the data layers, traffic news, the bikeability and walkability raster, and the level of service or the current traffic condition. A nice feature about this map is you can not only pan and zoom in, but you can also tilt it and move and look at the data from different perspectives. You could also do that in full screen mode, for example, which is quite nice, I think. On the top left, we have several key performance indicators, which show the latest value here, and also the change to its previous day as a percentage. Below that, we have information on the actual temperature and some weather information illustrated as icons. And to get more information on the weather, there's this button, which opens up a new window, and you can see data for the current and the next day. So the temperature, the rain, luckily no rain right now, sunshine, and wind speed. Below that, we have motivational judge, which is not situation aware, since we don't gather any user information in the dashboard and therefore don't know anything about user location or mobility preferences. And at the bottom is, bottom left, you can see a list of next public transport departures. When you hover over one of them, you can see the route. When you click on it, it will zoom to the extent of it. And another feature that only really makes sense if you're somewhere in the area of Salzburg, you can press this button, which will ask for your current location, and we'll update it. And since I'm in Vienna, it's going to hop over here. And it will also update the list of next departures. But since we only had data for the departures around Salzburg, so this would be my closest next departure. That was, I think, the dashboard. And finally, I will leave you with the vision for the DyMoN API, which looks something like this. So you can imagine many cities or areas having their own data hub, which are all connected to one instance of the DyMoN API. And the DyMoN API, again, forwards all those information to certain apps or many dashboards. And any mobile application with the notification system can adapt the DyMoN framework and receive nudges from the DyMoN API. So using this architecture would make use of existing resources and get rid of further standalone solutions, which are often costly and time-consuming to implement. And so this concept therefore can be seen as a quite easy and cheap solution for certain mobility problems. Thank you very much.
Thank you, Sebastian. Thank you, Martin. That was a very interesting insight into how to use data for sustainable mobility, into how you work, Sebastian. It kind of made me a little bit hungry because you kept talking about recipes and cooking and chefs. And before we go really quickly into the questions, I want to inform you that there is one more webinar coming up, the last and final one, where we talk about learnings and recommendations. And I've seen that there are a couple of questions in the chat that fit very well also into this webinar when we talk about effectiveness of nudges or how do we reach target groups and so on. So let's see how far we can get today. And otherwise, I will have to invite you to the next webinar so we can discuss these questions in detail. And I think my colleague will post the link to the registration in the chat. And of course, if you show the next slide, Sebastian, please. Yes. You can always contact our presenters or me directly if you want to exchange ideas or have your questions answered in details. We are very glad to help you. And yes, I think there are a couple of questions in the chat. We try to answer some of them already in the chat in itself. But maybe, Martin, there was a question for you about, let me see if I find it. What makes data more accessible rather than available? From Susanna.
Yeah, this is a brilliant question. Thanks for this, and I will be short in my answer. Availability means that the data exists, but maybe it is locked in any institution, stored on a local machine and not made accessible as open data, for instance. And currently there are many portals out there. The technology is mature, so everyone basically could make relevant data not only available but also accessible, so it is findable and it is machine readable, and you have the metadata with the data so that it can be used.
Okay, I hope that answers this specific question. I would like to take another question, and that was about how to reach a target group with a specific nudging app. And this is also something that could be discussed in the next webinar as well. So of course, this is always a challenge to reach a specific target group if you have people who drive their car continuously and are very in this habit, as Martin explained. In the DyMoN project, we used, as Sebastian said, a fitness and health app. So to shift the focus a little bit, we also try to bring in local companies for this. Maybe Martin, Sebastian, you want to add to this question, because this is a real challenge for many mobility projects.
Yeah, true. I mean, this is something where kind of experts like you, Claudia, who are coming more from the behavioral research side, from psychology, are relevant. What we can say from the data and technology side is that the architecture that we designed is perfectly adaptable to any user group, and so we can change basically all the parameters, all the thresholds, and make it available to whoever. So this was one of the requirements, to come up with a system that is adaptable and can address different needs and preferences of the users. The question of how to access different user groups, how to address their interests, this is really a tricky one, but it is not a technical one.
That's true. That's also a question of how you frame this sort of apps and these sort of mobility campaigns, but we will talk more about this really in the next webinar. And I'm not sure if we will be cut off from Zoom, but there was one very early question about recommending this system that we set up as an effective strategy for policymakers to incentivize sustainable mobility, or should they prioritize alternative methods and strategies? And at least from my point of view, and Martin, Sebastian, please add to this, I think we need all different kinds of efforts. So we cannot just nudge people and hope that everything changes, but we also should use the systems that we have, the data that we have. And maybe some final words or something to add from Martin's side or from Sebastian to this?
I would say that was perfect.
Okay.
There is one question in the chat asking how you can send a text nudge about cycling to a cyclist. Yes. So together with the location and the timestamp, we get the information on the preferences in terms of mode preference. This is stored in the app. So we get this information packaged in the request that is sent to the server, and accordingly we return the suitable nudges and delete the request. So we do not, in the framework we designed, we do not store the data, and we do not learn from the interaction with the user, for this very reason that is implicitly mentioned in the question, for privacy reasons. But of course, this would make it more targeted, more specific, if we could learn from the users and store the user profiles on our systems, which is not done for privacy reasons in this case.
Yes, thank you for explaining this one so well. And as far as I can tell, I think we have covered most questions. Feel free to get in touch or register for the next webinar. The time now really flew by, and we have filled an hour, I hope, with very interesting content for you. Please register for the next final webinar in February. And again, I want to thank the great speakers, Martin and Sebastian, for preparing such interesting presentations for us. And yes, with this, I would like to close the webinar now. And I hope to see you all in February then. Take care. Bye-bye.
Goodbye.